gents, I think you've been doing AI longer than most, before it was even cool. But maybe give a little bit of a quick intro. Maybe Neil, we start with you, and then Andrew.
Sure, absolutely. And Gordon's absolutely right. Can't actually see anyone up here. Very good. So assuming there's some people out there, Neil Taylor, I lead the AI and strategy teams globally for Mastercard. These teams support the business to enable us to develop and exploit our AI and data capabilities, and ensure that we're doing so with the appropriate safeguards and trust and security in place, but also to think of what's possible now. Think of the new opportunities associated with that. So that's what we do.
Thank you. Good afternoon, everybody. My name is Andrew McHutchon. I'm the head of data science here at McLaren. This might be the first time I've come on stage after having to watch a video of myself, which is a uniquely terrifying experience. But yes, we look after all the AI, machine learning, data science applications across all of the McLaren Formula One. I joined McLaren 12 years ago, straight out of a PhD, and became the first data scientist at McLaren. We didn't have the job title at that point. And now Silverstone marks my 250th Grand Prix here. And we've seen the team grow from what was sort of a solo effort all the way up to an entire team, and one that's not just an isolated team, but a team integrated across the whole of our racing organization. So it's been quite a journey over those years.
I remember during my time, you sat in a part of the building where there were more PhDs than chairs. How big's the data science team got? Can you share with us? Or?
So it's hard to narrow it down in a way, but we are engineers that are fundamentally taking data. And so in some ways, although I happen to have a job title with the word data scientist in it, there are probably a good 100 engineers who could in some ways conceivably call themselves that, because if you go down the boulevard here at McLaren, you'll see some of the cars from the 60s, 70s, where those cars were drawn by pen and paper, they were drawn from human experience, and that sort of level is just not possible anymore. Like the cars are so complicated, such that you can make a 1 millimeter change on the front wing and measure that 5 meters down the rear end of the car. So that the only way to develop that is through data. And actually, fundamentally, all our engineers, therefore, have to have some grounding in understanding the data that comes off the car.
And I suppose we've spoken a lot in the industry about these kind of turning pilots into production and how quickly people can do that. Your pilots here look a little bit different, not the drivers, we're not in America this week, but your pilots, they've got to go from testing to finding an advantage, and then suddenly, they're then critical to race weekend performance. Well, tell us a little bit, what does that look like, and how quickly are you iterating and building tools and data capabilities for the organization? Yeah,
I think it's really important. I think everyone needs to understand as well that AI will fail. Not 100% of your projects will work, or your products will work, certainly not first time. And this is something that we're sort of very comfortable with here. And when you're trying to push performance, you expect not every part to work. So when we design new parts to go on the car, not every one of them is going to work. And you just expect that, and then the ones that don't work, you're going to learn from them. So I think an AI project that we might start can I guess fail in two places. It can fail during a pilot, during our sort of test and development, and in some ways that's a good failure. That's where we want things to fail. And if they fail there, then nearly always it's due to a data problem. Fundamentally, what someone was wanting to do and the data that we had didn't have enough information in. There wasn't possible to build a solution that we needed, or to the accuracy that we needed from the data that we had available. And then you have the products which get, I guess, for us, it's not to market, but to track. And if they fail there, that's a bad failure, right? That's the goal where nothing should fail once it's got to that point. And it can fail because either it's giving you the wrong information, which is sort of the worst kind of those failures, where someone is trying to trust it, but it's actually incorrect. And then it can fail in it's just never used. So you've gone all the way, you've built something, it's brilliant at what it does, but what it does wasn't actually useful. Or it wasn't integrated enough into someone's workflow. You've had to go to one of our race engineers and say, we've got this brilliant new app, but you need to switch to this other program that you don't normally use. You need to open a new browser tab. You need to install this extra thing and then switch to that. And they're just like, I haven't got the bandwidth to deal with another new thing. So if we've not managed to actually bring that into someone's natural workflow, where it's going to be able to empower them without them having to switch and change an entire approach that they've been building on and have optimized very well for the last 10 years, It's very hard to do that. And so that's where we often see something fail, and we've deployed it and no one's using it. And that is also, we really don't want to get to that point. And I guess the advantage we have is that everyone who uses our products is in this building. We don't have the problem of customers on the other side of the world, where you maybe have never even visited the country they're in, let alone spoken to them directly. And so we really have this very close relationship between the engineers that use the tools we build and the developers. In fact, we can literally sit side by side and co-develop things. And building that, even if you're not able to bring your customers and your developers and put them side by side, maintaining the closest possible relationship between product team, between developers, between AI experts, between customers, users, and keeping that feedback as close as you can is ultimately the way that we get the most success.
I can imagine that's a bit of a challenge in Mastercard, given the global nature of what you do. How does it look different for you guys, Neil?
Well, I think, contrary to McLaren, we can't fail in the market. Yeah, if we release something out there and it fails, that's a problem. So there is a lot of testing and development that goes on, consequence to manage that. But I think the fundamental difference, particularly when it comes to AI, and actually I didn't get to ask my question of Gordon earlier on, so I'm going to ask him in a minute and challenge a bit on the network volume thing, because I think that 3x is massively underestimated. I mean, we've got 40,000 employees. In just 9 months, they've built over 17,000 agents, personal agents. Hundreds of those have been promoted to departmental agents. Some of those have been promoted to enterprise agents. Those agents are interacting with their co-pilots. They're interacting with the Claude code. They're interacting with the engineering tools and all the rest of it. The volumes of traffic are massive. They're interacting with the LLMs underneath. Yeah, it's huge. And as a consequence of that, we're thinking about, okay, well, we're going to have to rethink how we do memory for agents, because actually, we're not going to keep all the memory, the information in RAM or in GPU or in physical memory. We've got to think about how we do that. So we're thinking, okay, so you've got to re-engineer, you've got to think about key value pairs stores, you've got to think about graph databases underneath, you've got to think about the vector databases. How you then connect all those components together with our foundational model and other aspects. You've got a whole bunch of components that never used to be connected and talk to each other before, that have massive amounts of flow of information and data between them. And that's fundamentally different. And it's like, how are we... actually, Gordon, if you have a solution to that, it'd be really quite interesting.
We recently chatted to our Chief People, Policy and Purpose Officer, the 3 Ps.
You like the letters, don't
you? We do. It's a good job title. Wow. But we asked him, do you think she'll become the Chief People, Policy, Purpose and Agent Officer? So I'm fascinated to hear you've got departmental agents. What does that look like when you get inside the boardroom? How are you making that investment? Are people asking about ROI? Maybe share with some people, how does that look when you get up to the executive asking for funding?
I think the challenge for us is that the board have become massively more sophisticated in a very short space of time. Whereas, last year they were saying, are we doing AI? And we could go, yes, we're doing AI. They went, oh, well done, very good. Now they've kind of understood that just because we're doing AI doesn't mean we're doing AI effectively and all this. So they're now asking about return on investment. They're asking about value recognition. They're actually asking about what's the split between the value that the AI is delivering, the value that the human element is contributing. How do we understand it? How do we capture it? How do we measure it? And therefore, how are we redeploying that value elsewhere? And therefore, what are we actually getting in return for that? So they're asking much more tough and sort of perceptive questions. So the business cases that are going up to the board are equally now much more robust and much more sophisticated.
And you've got a different challenge, different sort of business challenges. You don't really, it's a race team at the end of the day, but you have this outside governance of a cost cap. And so ultimately, every dollar you spend, every freebie is all, the real value of it. How have you worked with, the leadership here and the team principals and Zach on explaining AI, and then, how have you also justified the investment for it? Because sometimes that must be a pretty hard trade-off between cars and technology.
Yeah, indeed. Because we have this cost cap, which is currently $220 million a year, but that covers everything from designing the car, racing the car, every employee's salary, all of those things come out, the infrastructure, long-term investments, everything comes out of one budget, and we operate exactly at that budget, which means if you're trying to make a business case for something, you're not just trying to say, this is worth this, you're saying it is worth more than this other thing we're already spending it on, because we have to take money away from that in order to put it on something new. Or you have to say this new product will save us money elsewhere and therefore sort of pay for itself. And that can certainly be a really challenging argument to make, but it certainly means you have to understand where your infrastructure spending is and where your research spending is, because you can't just lose track of it. Everything does have to come back to the goal, which for us is lap time, really, or points, winning world championships. But it can be very hard to make. How do you trace spending on tokens all the way through to whether you're going to win a race or not? There's quite a few steps that go through there. So I think fundamentally, for me, when I'm making these arguments, it comes down to two things, which is acceleration and enablement. And I need to get tips to make them start with the same letter.
Welcome.
I mean, acceleration, I guess we've spoken about quite a bit already, but AI should enable you to do what you currently do faster. Like, you should be able to, I guess for us, it's not getting to market, but getting to the track, and we should be able to get ideas through development and onto the race car faster by using AI than we currently do. And so we have a lot of very easy ways of measuring how quickly our performance goes from our development, say in our wind tunnel or in computational fluid dynamics. How far ahead is that car from the car on the track? We can design the fastest car in our computers, but ultimately that doesn't get us any World Championship points. We need to get those to track. And we measure that time frame in absolute maximum months, ideally in weeks. And so, a start of a project to an end of a project might just be 3 months. That would be a typical length of time. So it's very fast, but we have quite good measurement of that. So what we want to see is, as we deploy more AI, that time comes down. And that's something that we can get quite easily. And then it's very easy to translate that into the effect that we have on the car. And then the other one being enablement is, the other thing AI should do is not just enable you to do what you currently do faster, it should enable you to do new things that you couldn't otherwise do. And in fact, this is something that it's not just things you couldn't do 5 years ago, it can be something you couldn't do even 6 months ago, right? The rate of AI is changing so quickly that you can do a pilot, you can test something and realize, this isn't going to work, and then 6 months later, suddenly it does, just because the intelligence and the reasoning capability has leapt on so much. So there we can look for the things that we would never normally have been able to do, things that we've tried before, we couldn't do, or ideas that people have had, and have always just been that sort of wishful thinking. Wouldn't it be amazing if we could do this? And certainly whenever the driver comes in after a session, the first thing they're asked is, what do you need to go faster? If you could just wave a wand, what is it that you need to make this car faster? And then sometimes it'll be some simple things, but sometimes the new ideas will come out of those discussions, and you think, this just, we can't do this now. But then you start to apply the thinking and the innovation, and people start batting ideas around, and you slowly realize that actually technology is further ahead than maybe you appreciated. You think you try something and you think, this might actually work. And so I think that's the other thing that the sort of other argument you're going to make is, look at the things we couldn't do 3 years ago that suddenly we can do now. And to do that, you need to be keeping up with the cutting edge. You need to be understanding, where is the technology currently at, and the only way of doing that is to test things and to try things out. So I suppose that's when, going back to the pilots, of the good failures, or they tell you where the cutting edge boundary is, right? If you've got something that just doesn't quite work, well, you think, good, now I know where we are, and then I'll try that again in a few months when we've got some better data, or the models have got better, or whatever. So they're the two arguments that I tend to make.
And with the cost cap, that sort of, the idea of having an operating budget that you're trying to squeeze for people, for finance, for IT, kind of leads you down to not being so cloud-led, right? Unfortunately, that kind of pushes you back into a different technology deployment. How do you guys look at that with, the sort of constraints you've got on premise? I know from a couple of years ago, there was lots of rules around what you could have in your, CFD clusters. Yep. Just talk a little bit about that as well. Yeah, sure. So our infrastructure spending is definitely not what a typical company looks like. When many companies were moving to the cloud, we were moving back on-prem. And then that was because fundamentally for us, being able to make
infrastructure investments as capital expenditures was a lot better under the rules that we operated than an ongoing continuous expense. But ultimately, it has other benefits as well, which comes down to latency. Right? Everything that we do is about speed of decision making, and you don't often have time to be able to even do cloud hops. Some of our data, so the telemetry is not too bad, but we get a lot of images. We take hundreds of thousands of 8K photos over a season, and sometimes we need to turn results around from those in milliseconds. And you can't even upload the photo in that time. So we need a large amount, networking at that point, just being able to get your data from the source that you collected the data from to your intelligent agent, and then the results from that back to your engineer. Ultimately, if you can't do that within the time frame that you need, it's pointless even building the model. There's no point telling one, oh, you should have done this. I'm like, oh, well, great, thanks. You should have pit then. Everyone was like, yeah, great. Well, we know that now, but we needed to know that before we went past the pit lane. So that's where a lot of the effort has gone on to, is to work out how can we answer these questions whilst that's still useful. I mean, that must be something, there's no point saying to someone, oh, that was fraud, by the way.
Yeah.
You've already spent all your money, but
thanks for,
So those decisions must have to be done within a certain time frame to be useful.
I think it's strange. Like, people don't think about Formula One in the governance terms, and showing ownership of all your CFD clusters. Even the memory to core ratio is governed. For someone processing payments around the world, you also deal with a lot of governance. We were talking about governance earlier, and I thought, well, now what a better time to ask on stage. But yeah, what does that look like inside Mastercard, and how are you guys looking at governance with AI? I guess with the products itself, and then maybe your sort of adoption of AI tool sets.
Indeed, and actually, it's become a very sort of critical tool for us, because it's not just our own AI that we're having to understand the effectiveness of it, the capabilities, the bias, the drift, and everything else. It's everything in our supply chain. And our governance program is the only thing that can enable us to use AI within our supply chain. And that supply chain includes the hyperscalers, includes the foundational model, the frontier model builders, and others. And if we don't know that, if we don't understand those models, if we don't understand when they change, then the products that we've built on top of those, we don't understand when those change. So our governance programs are all built around, and our frameworks are all built around understanding, what are the sources of AI within not just our organization, but within all our supply chains and everything else. How are they performing? These are no longer one-off checks. When you used to build a product, and you'd go, hey, let's put this through governance. Governance give it a tick or a cross, and you go back. If you get a cross, and you go back till you get a tick, and then off you go into the market, into the wild. Governance is now a 24/7 permanent fixture and capability. And again, back to your network question or comment earlier on, the guardrails around our agents consume more tokens, more network capacity, more data than the actual underlying agents themselves. And as a consequence of that, you've got massive uplifts in need and demand. So again, we have to rethink about the engineering aspects and all the rest of it. And if you suddenly did, if bless them, lovely Anthropic or lovely OpenAI or whatever come along, and they don't always tell you when they upgrade their models. Sometimes they go from 4 to 4.5 or from 4.5 to 4.6. But 4.5 changes massively on an almost daily basis. And if you've got products built on top of that are serving customers in production environments, and you don't understand when that model has drifted or has changed or has done some behavioral challenge, you don't know what's going on. So it's fundamental.
Now, you've mentioned the network a few times. It's also another good answer to this question. But it feels like our ambitions are outpacing infrastructure at the moment. It doesn't feel like the infrastructure can keep up with it. Where have you seen that, kind of come to light? And what's the sort of trade-offs you've seen, maybe in like speed or cost, and what do you think we can do, and maybe we can do to help kind of close that gap a little bit?
So it's different in a couple of different places, actually. So if you think about Mastercard as the network, the global network, and you think about enabling agentic commerce now across that network. We used to just have the payment transaction going across the network. Now we have to enable the intent. So what did the owner of the agent actually intend the agent to do? So that's got to go across the network somehow, or an API alongside it. Then you've got to verify the authority that the agent actually has in order to carry out that transaction. So you've got to know about that piece. Then you've got to actually understand, well, who is the agent? Where's the agent come from? And so know your agent suddenly becomes important. Then on top of that, you started to get agents already interacting with each other in commercial environments through commerce. So in effect, you're enabling agent to machine. So all of that is now traveling across the networks. So on the network side, you've got massive amounts of thinking we have to do around scale and how we connect all that together. On the kind of internal side, and again, you've got to think about all the operations associated with how do we actually enable our workflow redesigns? How do we enable all our you talked about speed to product development and all the rest of it. We used to have a very lovely old-fashioned sort of SaaS product lifecycle of, you'd have a concept, you'd build a pilot and build a prototype, and then you'd scale that up and you'd build a minimum viable product and you'd scale that up and add features and all the rest of it. That doesn't work in the agentic space. If you don't have your agentic experience designed at the very beginning, then all you're doing is layering massive cost every time you go step by step by step. So that kind of old waterfall or that old product lifecycle approach just doesn't work for agentic design. And so you have to completely reevaluate that. Otherwise, your costs are going to be through the roof.
How about you, Andrew? So how long ago did you really start to get the investment for AI inside the team?
Yeah, I'd say a lot has changed over the last 5 years. And I think there are several reasons for it. Certainly, the growth of the language model has opened eyes amongst senior leaders of what is possible. Partly because there sometimes can be, you need to make sure there's a close connection between the technical capability and those who are leaders in the technical field, and those who are making sort of strategic decisions who might be one step removed from the technical capabilities. And that could have, what a language model was a perfect example was the ultimate and cutting-edge technology encapsulated in something that was really very beneficial for someone who was not technologically minded, who could interact with it and see the benefit and sort of test it themselves without just having to rely on, I always talk about AI, so if I go and say I need more money for AI, everyone's like, yeah, but you always ask for that. So here, this is something which was really very tangible, and I think that led to a lot of questions then being asked of, okay, now we've really seen what is possible, what else could we be doing? And that opened the doors to a lot of things that aren't language models. So I think, I guess one thing I'll be clear for everyone to understand is don't just look at language models. There are many other kind of models as well. The AI encompasses many different types of things. We do an awful lot of computer vision. A lot of things come in as video or photos. We have telemetry, which is the time series data. An awful lot of what we do has got nothing to do with language, and we don't use those models for it. But equally, you see more and more capabilities of a generalist model, right? A model which is able to understand the state of the world, is able to make sort of can learn something about some data over here and apply the same logic to your problem, which may have not on the face of it share anything with that original source. And so as we see those connections coming in as well, then things that weren't possible when you just wanted to stand up one or two people, here's a project, here's some data, make a bespoke model just to solve that, and that wasn't possible. Now you're able to bring this extra knowledge in from third parties, from data sets that seem quite disparate. And that's unlocked a lot more capability. And so that's led to more of a steamroller effect. I think there's very much there's a virtuous cycle of once you start deploying AI products that lead to good impact, then you win the trust, you win the belief that actually this is not just a flash in the pan. This is not just some sort of froth. Actually, it delivers real benefits, and then you sort of feed that back in again and go, okay, well now we need to chase this through. We need to actually be serious about this. How far can we take it? And so we really saw that start to take off within the last few years, which would I think follow the sort of exponential growth that everyone else is seeing, because I guess we crossed a few boundaries of what was possible and started really delivering more than just peripheral benefits, but core benefits. And that led to even more investment.
Well, I think we've got time for one more question, then we'll open it up to the audience. But I'm just going to ask you just a quick one. Do you get worried about security with AI? People, when they leave the team, if they're an aero engineer, you put them on gardening leave for a year and then they go off to another coloured team. Do you worry about security with an AI within your team?
Absolutely, yeah. I think anyone who doesn't worry about security is probably going to get bitten by it and very quickly then will worry about it. There are many different ways of doing it. It's very easy to have a sort of free-for-all. I guess one of the benefits and challenges of AI is that anyone can do it with a laptop. Or a laptop and an internet connection is pretty much all you need to be able to access incredibly powerful reasoning machines. And that could be something that you do at home on your laptop. It could be something you do connected to your corporate network. You could take your laptop from your corporate network and take it to back home with you. So being able to connect into these very powerful models and not knowing, if you don't know, what are people putting into it? What are people copying and pasting emails in and saying, please rewrite this, and that email is full of confidential information or customers' details. And where is that going? What's happening? Or even further, what data have we put out there that we thought was obfuscated, but actually these AI machines are now able to put back together again. And there's been plenty of examples of anonymized data that turned out not to be very anonymized because agents were able to make all the connections and piece things back together again and figure out who people were on the data. So I think you need to have a very broad view, but equally, you need to have a sensible risk level, because if you just try and lock everything down, then ultimately you're going to be at the point of saying, well, don't use anything, don't touch anything, we're going to shut everything down, and you don't innovate. So I guess you have your risk profile and understand where you want to be along that and what is an acceptable risk and where and what takes you too far.
I'm sure some of the other teams might have appreciated some of your data going into the open models, might have helped them out a bit this season. But Neil, just coming to you last, and then we'll open up some questions, and maybe your take on this, Andrew, as well. What's the sort of most important lessons you've learned on your AI journey that have really reshaped how you approach it?
I think the understanding the fundamentals. So we've had challenges getting stuff from prototype into production. And that's because we hadn't truly understood the new sort of economics around AI and the new ways that you have to work in terms of design, the experience, and everything else that's going to go. So that was kind of a big lesson. Getting some of the fundamentals in place, the long lead time stuff, the ideas for AI come very fast. The ability to code is now very fast. The ability to prototype and experiment is very fast. But actually, if you're going to go into production with something, having kind of a lot of the fundamentals there in place, in time, available for it to actually run on and build and all the rest of it, those are still long lead projects, and they don't work at the same speed as the data scientists and others that are trying to launch all this stuff. So it's like, okay, let's make sure we've got the fundamentals, and that's infrastructure, it's governance, it's those aspects, I think.
Sometimes those things catch you out as well. We had an example when we were first deployed things. One of our models went down in one of the races. So of course, big problem. But we noticed all the other models suddenly went twice as fast. And what we just had not appreciated was that there was shared resources between those models. And the one, they were throttling each other. And it was only when one of them happened to go down that we suddenly noticed that. So absolutely, if without making that infrastructure investment.
And if the engineers haven't understood which to prioritize in the tech center, then you're right.
Okay, awesome. Well, I'm sure people might have some questions for you both, given your experience and what you do with AI. So I'd like to open it up. If you've got any roaming mics, any questions? Yeah, I'll take one from there.
Thank you. You talked about in McLaren having just co-location and close proximity of product, engineering, data. Can you go into that a little bit more, like with an example, so that we understand how to make it work? How does that proximity, how do you extract value from that proximity of people?
Sure. I guess fundamentally we start with what are we doing as a data science team? Like what products or projects do we have on our board that we're going to work on? And we always start there with conversations with engineers, with asking them that question of what do you need to go faster. It's very easy to start with the technology and say, what can I do with this? Whereas it's much more effective usually to start with the people who are actually going to use it and what do you need. And so having really regular conversations, I have regular catch-ups with people across the whole, from aerodynamics through to manufacturing strategy, just to sort of understand what are their current bottlenecks. Can I sit down and watch them do something, or can people in my team, we even do placements sometimes where maybe someone in my team might join an aerodynamics team for a month or something, just to really understand what are they doing, what do they tick, and how therefore could we maybe make them faster. So that would be the sort of genesis of the ideas. Then every project that we start, we'll make sure we have key stakeholders who are ultimately going to be the people who use it, whether that be our race engineers or strategists. And then giving them prototypes, giving them pilots really early. We can do a lot of co-location, literally sitting in the bay next to each other. And then you don't always need to do, like, sometimes you just need to get away and develop, right? And then you do need to protect that time as well. Like, if you sit down in the aerodynamics bay, you're going to say, we're going to sit here and work on this product, and then you'll just get endless questions of, oh, this thing broke, or whilst you're here, could you also add this? And which can be great, but equally it can slow you down. So sometimes you need that focus time. But then it's just being really close to people when they're using it. So we might try and take people out to track to watch. You have a new product deployed. Or we might take it to, we can do testing with a previous car. The rules allow us to take one of our old cars and race it a few times a year. And so that's a really good environment where it's much about the pressure of a race weekend. And then you can really see how people are using the new thing that you've done. And then I guess finally, just lots of metrics. We measure every time everyone uses one of our tools, how long did they use it for, where did they get it from. We haven't got so much data sharing problems because we're all within one organization, so it's not quite so worried about spying on everyone. About when was that opened? What were they doing beforehand? How long did they stay on this? What did they click on? Did they get lost and then close it and never use it again? So a lot of those really, really tight feedback circles.
Great, thank you. And just out of interest, does your token usage come out of your cost cap?
Yes.
Wow.
Yes, indeed. Lots of conversations about that recently.
Any other questions?
Just on the topic of trust, we're trying to give these tools to loads of people. We want them to make the best of them. We want the people to make the best of the tools. How do you balance between kind of giving everything to everybody and enabling everyone to do everything versus runaway costs and people snooping on each other and whatever else?
Neil, do you want to give that one a stab first?
In the same way that we ensure trust in many other aspects of how we do business. You have employee policies, so your people are responsible for the tasks they carry out and the roles that they play. So trust goes both ways. You have to trust your employees that they understand what their jobs are and they understand what they do. But then there are physical and sort of process controls that you can put in place to wrap around those tools. So ensuring that contractually that your contracts with your suppliers, be it the hyperscalers or smaller supply chain companies, include all the necessary safeguards, that they're actually being complied with, that you have good audit capabilities and good audit rights and aspects like that, all the way through to then technical controls that prevent data leakage by preventing people putting code documents into the prompt screens, or preventing agents being able to activate other agents, or ensuring that the agents are not able to share passcodes with other agents or authentication capabilities and things like that. So there's a whole range of controls that go into ensuring that we can be trusting of the environment that we create.
And in fact, I would turn it around slightly and say also, a comment that sometimes I would hear would be, I didn't want to try it because I was worried that I would do something wrong or that I would, break a rule or, cause a problem. So I haven't tried AI. And to get your employees to really push and innovate, they need to feel they're in a trust environment where they can try things, experiment, and it not cause a major problem. So we try and provide a very clear paved pathway. If you're in this tool, using these apps, it's safe. The data is all covered by enterprise agreements or by safeguards, and you can try what you like. We've got a budget cap in place, so you're not going to accidentally cause the whole cost cap to be spent. And that really encourages people and enables them to be free to do that. But you also have to balance it on, we don't want to talk about costs too much. Like, yes, there's a cost cap and we have to balance it, but we try and manage that at a strategic level and not cause every engineer to worry about that. Because yes, you want people to be efficient with how you're using it, but equally you don't want them to be so worried about it that they never try it and that never really push the boundaries. And we very much believe that by AI is a democracy in many ways. By democratizing it and letting every engineer be able to interact with it, you could unlock things far more powerfully than just have a central team sort of say, this is how you're going to use it. There are going to be ways that AI is used that we have no idea about right now, that I've not even thought about, but people will discover them. So we really want to enable that as much as possible. And so if you scare people too much about it with, what's your costs, what's your security, what's all these things, then it sort of stifles their innovation. But if you build it into the tools that they can use and then say, right, go wild, knock yourself out, really try in all the different things and don't worry, we've put the governance around it that you don't need to concern yourself with, then that really, I think, is a good way that that it's going to be safe, they know it's going to be safe, and hopefully that gives you a really clear performance gain.
Let's join me in giving a huge round of applause to Neil and Andrew. Thank you very much.